Okay, now we'll discuss the solution to exercise 13-11 on page 610. This problem has us compare two projects using the net present value method. The way the problem starts is that Sharp Company has $15,000 to invest, and the company is trying to decide between two alternative uses of the funds. First alternative is invest in Project A, which requires a $15,000 cash outlay, where the annual cash inflows will be $4,000 per year, and the life of the project is 10 years. The alternative is to invest in Project B, where the same $15,000 of investment would need to be made on day one. There would be no annual cash inflows. However, there would be a single cash inflow at the end of 10 years in the amount of $60,000. So both projects have a lifespan of 10 years. The timing and the amount of cash flows are different between the two alternatives. Sharp uses a 16% discount rate. They want to know which investment would we recommend the company accept. Show all computations using the net present value method. Alright, so if we were to look at Project A and calculate the net present value of Project A, we would need an investment today of $15,000. So there would be a cash outflow of $15,000 now. That present value would be $15,000 cash outflow. The cash inflows would be $4,000 per year in each year for 10 years. When we go to the table at the end of Chapter 13 on page 630, present value of an annuity, we can see that the discount factor is 16%, number of periods is 10. So on Exhibit 13B2, we would go across to 16%, down to 10 periods, and see the factor 4.833. That 4.833 discount factor will be multiplied by 1 year's worth of cash flows. They're even cash flows. That's the description of an annuity. So $4,000 multiplied by 4.833 gives us the present value of the cash inflows to be $19,332. So the present value of the cash inflows is $19,332. The investment required is a $15,000 cash outflow. Our net present value is a positive $4,332. It tells us that Project A would be acceptable because it does have a net present value that is positive. When we look at Project B, alright, Project B once again has a cash outflow today of $15,000. Present value of that $15,000 today is $15,000. There's only one cash inflow with this project, and it comes at the end of year 10. So, and the amount of it is $60,000. So we need to take the present value of that one-time cash flow of $60,000, and in order to do that, we will go to page 629, the present value of a single amount. Present value of a single amount on page 629, Exhibit 13B1. We would go across the top to 16%, down to 10 periods, because it's 10 years from now upon which we'll receive it, and we see the discount factor of 0.227. That 0.227 will be multiplied by $60,000 to give us the present value of that one-time $60,000 cash inflow, and that amounts to be $13,620. When we add that to the $15,000 cash outflow that happens today, we have a net present value of a negative $1,380. So $1,380. So the net present value of Project B is negative, and we know that when the net present value is negative, that project is not acceptable. So in comparing the two projects, obviously Project A should be selected. Project B will not provide the required 16% return, as demonstrated by the negative net present value. This does it for our discussion of the solution to exercise 13-11.